Yes, class. Today I will discuss about the adsorption and types of adsorption. Okay. So first of all, what is adsorption? Okay. Adsorption means the accumulation of the molecular species on the surface of the adsorbent is known as adsorption. Okay, class, what is adsorption? Adsorption is the accumulation of molecular species on the surface of the solid or adsorbent is known as adsorption. During the adsorption, there is a force of attraction between the adsorbate and adsorbent. Therefore, some amount of heat released during the adsorption. Okay. So next, what is adsorbate? Adsorb means the molecular species, that is the either gases or liquid which can adsorb on the surface of the solid is known as adsorbate. And adsorbent weight, and the adsorbent means the solid surface or it may be liquid at which the molecular species are adsorbed. That is the adsorbent. Okay. And next अगर आप देखें बेटा, during the adsorption there is a force of attraction between the adsorbent and adsorbate. Therefore, some amount of heat is released. It means the process is exothermic. Means delta H is negative. Delta H is negative. And the reverse process of the adsorption is known as desorption. The next is desorption. Desorption means simply the reverse process of the adsorption is known as desorption. Or you can say define the desorption like the removal of the molecular species from the surface of the adsorbent is known as desorption. It means अगर आप molecular species को remove कर देते हैं from the surface of the solid, that process is known as desorption. And desorption can be done either by increasing the temperature or by reducing the pressure. And next is absorption. Absorption is the bulk phenomena. And what is the meaning of the bulk phenomena? Means the molecular species have overall or throughout the same concentration in a material or in a adsorbent. That is the absorption. What is adsorption? Adsorption means that is the bulk phenomena. Okay, that is the bulk phenomena. And how can you differentiate between the adsorption and absorption? First of all, adsorption is the surface phenomena. Okay, and absorption is the bulk phenomena. Means in absorption, the molecular species are present overall or throughout the material, throughout the adsorbent. So the basic difference between the adsorption and absorption is, first is the adsorption is the surface phenomena, whereas absorption is the bulk phenomena. Okay, and second, In a adsorption, there is a concentration only at the surface of the adsorbent. But in a absorption, there is a same concentration throughout the material. That is the absorption. And third difference between the adsorption and absorption is, in adsorption, the rate of adsorption in the beginning is fast and then it becomes slow and they achieve the equilibrium state. But in case of absorption, the rate of adsorption is almost homogeneous or similar. So these are the differences between the adsorption and absorption. And the next term is, that is a absorption. Absorption means if the adsorption and absorption both takes place simultaneously, then the process is known as absorption. So there are three main important terms like adsorption, desorption, absorption and absorption. Clear, class? Okay. Next, absorption in action means what is the evidence in the support of adsorption. Okay, that is the adsorption in action. And the first is the activated charcoal are used for the adsorption of different gases. What is the use of activated charcoal? Activated charcoal is used for the adsorption of different gases like sulfur dioxide gas, carbon monoxide gas, HCl gas, and that is the important use of the activated charcoal. And the next is animal charcoal. Animal charcoal is used for the decolorization purpose. Means it is used to remove the color from the coloring substance, and especially in a sugar industry, a brown color of the sugar is removed by using the animal charcoal. And the next one is silica gel. Silica gel is used to remove the moisture content. Okay, so these are the adsorption in action means uses. अगर आप देखें adsorptions के, that is the first is activated charcoal used to remove the different gases. Means either it is used to create the vacuum or it is used to reduce the pressure. And next, animal charcoal, it is used to remove the color from the coloring substance. Especially in a sugar factory, it is used to decolorize the brown color of the sugar. And the next, silica gel, it is used to remove the moisture. Okay. And next beta, important thing, that is the factors affecting adsorption of a gas on the solid. Means what are the factors at which the adsorption depends? And the first factor is First factor is nature of gas, that is the adsorbate. This is the important thing. Nature of the gas are adsorbate. Especially, it can be explained on the basis of the critical temperature. TC indicate what? Critical temperature. Higher the critical temperature, easier the liquefaction of the gas and greater the rate of adsorption, greater the rate of adsorption. That is the important point. It means the first factor is nature of the gas are adsorbate and it depends on the critical temperature. Greater the critical temperature, greater will be the adsorption rate. For example, sulfur dioxide and methane, there are two gases. The critical temperature of the sulfur dioxide gas is greater than the critical temperature of the methane. It means sulfur dioxide gas easily adsorb or readily adsorb on the surface of the adsorbent as compared to the methane. Okay, so that is the first factor. And the next factor is surface area of the adsorbent. Next, surface area of adsorbent. The next factor, that is the surface area of the adsorbent, means greater the surface area of the adsorbent, greater will be the adsorption. Okay, the second factor is the surface area, means it depends on the surface area, and if the surface area is greater, then the rate of adsorption is greater, or extent of the adsorption is also greater. And the next factor is, that is the temperature. Okay, next factor is temperature. टेम्परेचर बेसिकली अगर आप देखें तो बिकॉज द रेट ऑफ या द नेचर ऑफ द एडजॉर्प्शन इज रिवर्सेबल एंड एक्सोथर्मिक इन नेचर, it means we can explain easily by using the principle, that is the Le-Chatelier principle. Means if the process is reversible and exothermic, then on increasing the temperature, the equilibrium shift backward. It means adsorption extent or adsorption rate decreases. It means the temperature effect can be easily explained on the basis of the principle, that is the Le-Chatelier principle. Okay, because of the adsorption is reversible and exothermic in nature, therefore always low temperature favors for the adsorption. Okay, and the next factor is pressure. Next factor is pressure, and usually on increasing the pressure, the extent of adsorption increases, but it can be easily explained on the basis of the graph between adsorption and pressure. Okay, so it means pressure effect can be explained on the basis of the graph between the adsorption and pressure at a constant temperature. Okay, and the graph is like this. It means up to the certain pressure, the adsorption is directly proportional to the pressure, and then the adsorption decreases on increasing the pressure, and finally it will approaches to the saturation pressure, means the rate of adsorption and the rate of desorption both are same. So these are the factors. Again, first is the nature of the gas, that is the adsorb weight. Nature of the gas, it depends on the critical temperature. Okay, higher the critical temperature, greater will be the adsorption. For example, sulfur dioxide, more critical temperature as compared to the methane. It means sulfur dioxide easily adsorb on the surface of the adsorbent as compared to the methane. Next factor is surface area of the adsorbent. Simply, larger the surface area, greater will be the adsorption. And the next factor is temperature. Because the adsorption is reversible and exothermic in nature, therefore a low temperature favors for the adsorption, or especially in a case of physisorption. But in chemisorption, basically it favor at high temperature. And the next factor is pressure. And in general, on increasing the pressure, adsorption increases. But it can be explained also on the basis of the graph between adsorption and pressure at a constant temperature, and usually at a low pressure, adsorption is directly proportional, or extent of the adsorption is directly proportional to the pressure, and then it will decrease, and at a saturation pressure it achieve the equilibrium state. Two types of adsorption. How many types? There are two types of adsorption. That is the physical adsorption and chemical adsorption. First thing, what is the physical adsorption? If there is a weak van der Waals force between the adsorbate and adsorbent, then it is known as a physical adsorption, that is the physisorption. Okay, and if there is a chemical bond formation between the adsorbate and adsorbent, then it is known as a chemical adsorption, or it is also known as chemisorption. It means in physisorption there is a weak van der Waals force of attraction, But chemisorption is due to the chemical bond formation, either it is covalent or ionic in nature. Physisorption is not specific in nature, means any gas can adsorb on the surface of the adsorbent because of the van der Waals force is the universal force. But chemisorption is highly specific in nature due to the formation of the chemical bond. And next is physisorption is reversible in nature, but chemisorption is irreversible in nature because of the formation of the chemical compound. For example, if a adsorbent is metal and adsorbent is oxygen, then there is a formation of the metal oxide. Therefore, it is non-reversible or irreversible in nature. Physisorption depends on the nature of the gas, means higher the critical temperature, easier the liquefaction and greater will be the adsorption. That is the physisorption. And chemisorption of the gas, it depends simply on the nature of the bond formation. Okay? And the enthalpy of adsorption in case of the physisorption is low, and its value ranges from 20 to 40 kilojoule per mole because of the weak force of attraction between the adsorbent and adsorbent. But in chemisorption, the enthalpy of adsorption is high, that is 80 to 240 kilojoule per mole because of the bond formation, that is the chemical bond formation. Either it is covalent or it is ionic in nature. Usually, a physisorption favors at low temperature because of it is reversible and exothermic in nature. Therefore, low temperature favor for the physisorption, but chemisorption usually favors at high temperature. It means on increasing the temperature, chemisorption increases. In case of physisorption, usually there is no appreciable activation energy needed, but in case of chemisorption, there is a requirement for the activation energy. Next, physisorption depends on the surface area, means greater the surface area, greater will be the physisorption. Chemisorption also depends on the surface area, means greater the surface area, greater will be the chemisorption. Next is the important point, that is the physisorption forms a multimolecular layer. Physisorption forms a multimolecular, that is a layer number 1, layer number 2, layer number 3. That is a multimolecular layer between the adsorbate and adsorbent. But chemisorption forms unimolecular layer because of the again a formation of the compound between adsorbate and adsorbent. So these are the important basic differences between the physisorption and chemisorption. Okay, class.